Hey everybody, welcome to another Physics in the Flesh video, example 4 for vectors in two-dimensional kinematics. So, graphically determine the resultant of the following three vector displacements. 1, 34 meters 25 degrees north of east, 2, 48 meters 33 degrees east of north, and 3, 22 meters 56 degrees west of south. So I'm not only going to show you how to find the following displacement, the final displacement rather, but how to draw these vectors and interpret how they write it. Okay, so the first one is 34 meters 25 degrees north of east. That means you start in the direction east, and I've got my Cartesian plane already drawn out here. You start at east and you go 25 degrees up to the north. Okay, so that's going to be relatively about there. And keeping in mind the length of my vectors, I've got a 34, a 48, and a 22. 34 is in the middle, so I'm going to draw a mid-sized vector here. Okay, so that should do it. So that's going to be my D1. And that angle right there is 25 degrees, so go ahead and label that in your picture. Okay, D2, excuse me, is 48 meters 33 degrees east of north. So this time you start at north and you go 33 degrees east, so that's going to be roughly there. And this is 48 meters, the longest vector, so I'm going to draw it up here. So that is D2, and the angle here is 33 degrees. Okay, and D3, 22 meters, 56 degrees west of south. That means you start at south and you go 56 degrees to the west. So 45 is the middle line, right, because each quadrant is 90 degrees, so you go a little bit more and you're going to be at roughly 56. So, and that's 22 meters, so that's a short vector there. So that is D3, and the angle 56, make sure you label the right side, 56 degrees. Okay, so you've got our picture all labeled, and you'll notice just from the picture this is much different than the earlier three examples in that every single one of these single displacements is going on an angle relative to the north, east, south, and west. None of them are actually in line with the north, east, south, and west. So we're going to have to do one more step, but you know what? It's still pretty straightforward for these questions. So all in all, we're looking for the resultant displacement, right? D sub r. And D sub r is going to be a combination of D1, D2, and D3. Now, you can write that. You can write that down, that dr is equal to D1 plus D2 plus D3. It's correct. But the way I want you to think about this now, since we've got so many different ones on different directions and different angles, I want you to think of it as this. Each one of these vectors has an x component and a y component. For example, if you took D1 and you drop the arrow down to the x-axis, you could do a right angle there. So you've got a right angle triangle. D1 would be the length of the hypotenuse. You would have D1x as adjacent to the 25 degree angle and D1y as opposite to the 25 degree angle. That's how I want you to think about it. You can do the same thing with D2. You can drop a vertical line down. D3, put a vertical line up to the x-axis. Okay. So how I want you to look at this is that the resultant displacement is made up of a resultant in the x direction plus a resultant in the y direction. Okay, this is going to make it really simple for you to solve this. Okay, so we're going to start off with the x direction first. Okay, so let's do that first. We're going to do all three x directions, and then we're going to go ahead and do the y. You know what? Let's actually do this on a different piece of paper, because this is going to take the entire width of the page to solve. So let's do it like this. So for the x direction, so D resultant x, okay, is equal to the x component from 1 plus the x component from 2 plus the x component from 3. Pretty straightforward. You just write down your formula first, okay? Now the x component from 1, let's take a look. X component from 1, that's this part right here, right? So what you need to do is, based on your understanding of trigonometry, you take your hypotenuse, which is D1, and you multiply that by the cosine of the angle 25. Okay, right? Because cosine is adjacent over hypotenuse, and it is your adjacent that's giving you d1x. Okay, so d1x is d1 cosine 25 degrees. Okay, and that is going east. Make sure you write down your directions. d2x, now be careful with d2 here. Don't use the wrong angle. If you drop that down, d2x, if you want to look at it as being this number right here, if that is a d2x, then you have to use the angle here, right? If you're using this triangle, you have to use this angle. Okay, so therefore, if that's 33 degrees and the total is 90, 90 minus 33, right, is going to be 57 degrees. So therefore, we're looking at the cosine, the adjacent of this angle, which becomes the cosine of 57 degrees. Okay, so plus d2 cosine 57 degrees, and that, notice it's also going in the east direction. And d3, okay, so if d3, you put it up to the x-axis, or here the negative x-axis, you're going to have your d3x and your d3y. Notice again, just like d2, we're using a different triangle here. So we're going to work with this angle. The angle there is going to be 34 degrees. So therefore, d3x, this component right here, is going to be the hypotenuse times cosine of 34 degrees. But something you have to take note, this is not going east. This vector is actually going to go west. Okay, so plus d3 cosine 34 degrees west. Okay, so far so good. Now we actually know what d1, d2, and d3 are, so we can actually just plug those in. Right, those were given to us in the question. d1 is 34, d2 is 48, d3 is 22. Okay, so let's go ahead and keep working that out. Again, we're just doing the x direction right now. So I'm going to move my equal sign a bit more to the left here. I'm going to need a bit more space. Okay, so d1 is 34, so 34 cosine 25 degrees east, plus d2 is 48, 48 cosine 57 degrees, also east, plus d3, which is 22 cosine 34 degrees west. Okay, so at this point, you have to just look at this and realize, you know what? This 34 cosine 25, or 48 cosine 57, or 22 cosine 34, that's just a number. Those are just numbers. So we're going to get a number east, plus a number east, plus a number west. Okay, so when you plug this into your calculator, 34 cosine of 25, you should be getting 30.81. If you're not getting that, make sure your calculator is in degrees and not radians. I know I make that mistake all the time. Okay, so 30.81 east plus 26.14 east plus 18.24 west. Now, we saw something similar in an earlier video when we were dealing with north and south. Just like north and south are opposites, east and west are opposites. Okay, so that means that positive north equals negative south, and vice versa. Okay, and so based on that example, we can actually change that to, for this one, east and west, right? We can say that positive east equals negative west. Okay, so because we have west here, that's actually going to become negative east. All right, so let's move this up a bit more. 30.81 east plus 26.14 east. Now instead of plus 18.24 west, that's going to become minus 18.24 east. You're adding the negative, or in other words, you're subtracting. Okay, so now everything's in the same direction, so we may treat this now as a linear problem. So all we need to do is 30.81 plus 26.14 minus 18.24. And when you do that, you're going to get a resultant drx of 38.71 meters east. So there's our x direction for the resultant. Now we got to do the y direction. Yep, the fun never ends in physics. These problems just get longer and longer. Yeah, I know. I can see a lot of you shaking your heads there. Okay, so there's x. Let's work with the y direction now. Let's do that in orange. So for the y direction, we're going to do the same thing. We're looking for d resultant in the y direction. And so that's going to be comprised of x in the y direction, so d1, pardon me, 1 in the y direction, d1y plus d2y plus d3y. Okay, and because we're working in the y direction, take another look at that diagram. For the y direction, like for example here for d1, this is going to be the sine at the angle 25 degrees. I know the image has gotten a little bit cluttered at this point, but this is essentially what you're looking at for d1, for instance. If you've got d1, you've got your 25 degrees. You've got d1y, d1x. We found d1, well, d1x you can determine. d1 we have, it's 34. So all you have here is 34 times the sine of 25 degrees gives you this opposite side of d1y. And this is a right angle triangle, by the way. You're essentially doing that for all three of them. Okay, so so d1y, it's going to be the magnitude d1 times the sine of 25. d1 is 34, so it's going to be 34 sine of 25 degrees. And now again, let me bring this back up on the screen. d1 is going north, d2 is going north, for y I mean, and for d3y we're going south. So just pay attention to that right there. Okay, so this is north, plus 48 sine 57 degrees. d2y is also going north, excuse me, and d3 is going south, 22 sine 34 degrees, S for south. Okay, and just like before, this is a math problem. 34 sine 25, that's a number. 48 sine 57, that's a number. 22 sine 34, that's a number. Okay, so 34 sine 25, you're going to get 14.37 north. 48 sine 57, 40.26 north. And 22 sine 34, 12.30 south. Okay, so let's actually, running out of space here. Okay, so let's go ahead and combine those together. Okay, so just like before, we've got a south here. South is the same thing as negative north. Okay. Positive south equals negative north, and vice versa. I hope you can see that there in the corner. It's just like before. East is negative west, west is negative east, south is negative north, north is negative south. Okay, so rewriting this statement, let's just make that straight. Rewriting this statement, 14.37 north plus 40.26 north minus 12.30 north. So make the plus a minus and replace south with north. Again, now it's just a linear problem. They're all in north, so you can just do 14.37 plus 40.26 minus 12.30. And when you do that, you're going to get your resultant in the y direction to be 42.33 newtons north. Okay, so now we've got the resultant in the y, we've got the resultant in the x. Okay, so we're going to combine them. Okay, so recall the dr is equal to the resultant in the x plus the resultant in the y. Okay, so if you recall, our resultant in the x was 38.71 going east, and our resultant in the y direction is going in the north direction. Okay, I realize I'm using x and y. It's just a really convenient way to keep track of it. Although x and y are not necessarily always the same as east and west, this is just a system I use to help it make sense to me. Okay, okay, so let's proceed. So we've got 38.701 in the x, we've got 42.33 in the y. Okay, so we're going to go x, y like this. So there's our drx, 38.71 meters, and then we've got our y, which is a little bit bigger than that, dry, which is 42.33 meters. Since one is going east, one is going north, they meet at a 90-degree angle. Let me just move that up. And if you remember from before, you draw your resultant from the tail of the first vector to the tip of the second in that order. So let's go ahead and draw that in. So that is my resultant right there. Okay. So just like in the previous problems, in order to find the magnitude, it is a right angle triangle. I'm going to use the Pythagorean theorem. Okay. So the magnitude for dr is equal to the square root of 38.71 squared plus 42.33 squared. Okay, when you solve that, you're going to get 57.36 meters. And now, again, you have to go back to the original question to do sig figs, right? So all of our values have 2 sig figs, so our answer can only have 2 sig figs. Okay, so if you round 57.36 to 2 sig figs, you're going to get 57 meters. So therefore, resultant displacement is 57 meters. That's just the magnitude, obviously. We have to still find the direction. Okay, so again, your angle theta is from your first vector to the hypotenuse here. That's your theta. Theta here, these two we know for sure. We're going to use tangent. So we're going to do tan of theta is equal to opposite, which is 42.33, over adjacent, which is 37.71. So when you solve this value right here, you're going to get 1.0935. So we have to take the inverse tangent of both sides, therefore to get theta by itself, 1.0935. And when you solve that, you're going to get theta to be approximately 48 degrees, and that is to 2 sig figs. Okay. So again, now we have our angle, we have to express it accurately, right? So this, remember, is in the east direction. This is going in the north direction. So if we start here and our resultant's going in this direction, that means we started at east and we went 48 degrees north. Okay, so 48 degrees north of east. So we can therefore quote our final displacement, dr, as 57 meters, and again, putting our direction in brackets, 48 degrees north of east. So you got your magnitude, you have your direction, everything's correct to 2 sig figs, and that is it. Hey guys, if you like this video, be sure to give that like button a click. Subscribe to Physics in the Flesh to see more videos from me, more solutions to more in-depth physics problems. And that's about it. Stay tuned for my next video, and I will see you guys next time. Thank you so much for watching.